In this video, we are going to solve some problems on Newton's laws. So we have got two blocks which are being pushed along a horizontal frictionless surface by a force of 20 Newton to the right as shown in the diagram. The force that the 2 kilogram block, so the force that the 2 kilogram block exerts on 3 kilogram block is, and then they have given us some choices. So we want to find what's the force which 2 kg applies on 3 kg block. So the first thing, we know that because you are applying a force and there would be an acceleration for the system as it's on the frictionless surface, and 3 kg as well as 2 kg will have the same acceleration as that of the system. The first thing we'll find what's the acceleration of the system, which will be F net over the mass. So acceleration will be 20 over the total mass is 3 plus 2, which is 5. So acceleration will come out as 20 over 5, which is equal to 4 meter per second square. Now that's the acceleration for all the blocks, in this case 2 blocks, both of them will have the same acceleration, which is 4 meter per second square. Now we want to find out what's the force exerted by 2 kg block on 3 kg. So for 3 kg, if I want to draw the free body diagram for 3 kg mass, so this is our 3 kg mass, it experiences a force of 20 Newton to the right, as well as the 2 kg block will push it to the left. So this F is the force of 2 kg on 3 kg block. So we can write F net equal MA. This is for 3 kg block. So 20 minus F, that is a force of 2 kg on 3 kg, is equal to the mass, which is 3, multiplied by the acceleration is 4. So we can find this force which the 2 kg block will apply. That will be equal to 20 minus 12, which is equal to 8 Newton. Let's look at another question of similar kind, but this time we have got a string in between the two blocks. When the frictionless system, so again there is no friction, it's frictionless system, shown above is accelerated by an applied force. There is an applied force of magnitude F. The tension in the string will be, so we want to find what's the tension between the two strings. So as usual, the first thing what we will do is find the acceleration of the system. So acceleration is F net over the total mass. So in this case, acceleration will be equal to F, that's the net force which is acting on the system. There is no friction. So this is, we are doing it for the whole system, not for one block, but for the whole system. Therefore, the mass will be 2 plus 1, which is equal to 3. So that's the acceleration. Now we know that both the masses will have the same acceleration. And we want to find what's the tension in the string. So we have to consider one of the masses and draw the free body diagram for it. So let's say we want to draw the free body diagram for the 1 kg mass. So for 1 kg mass, the only force which will act on it is the tension force, which is trying to pull it to the right, and because of which it should have the same acceleration as that of the system. So F net equal MA, we'll apply this for 1 kg. F net is the tension force, that's the only force acting on it. The mass is 1, and the acceleration we just now found, that is F over 3. So we get the tension as F over 3. So our answer here will be E. Let's look at another problem with 3 blocks. So we have got 3 blocks. Again, the surface is frictionless and an applied force of 30 Newton is being applied on the system. So it's being applied to the 10 kg mass, and there is no other force which is acting on any other block. The question is asking you calculate the force applied by the 10 kg on 4 kg block. So as usual, the first step will find out what's the acceleration of the system, which will be F net over the total mass. So acceleration will be 30 over the total mass is 10 plus 4 plus 1, that is 15. So acceleration will come out as 2 meter per second square. Now for 1 kg, so let's just draw the 1 kg and 4 kg masses separately. 4 kg. There's no friction on the surface, so the only force which will act is a force of 10 kg on 4 kg block, and that's responsible for any motion or any acceleration which these two blocks will have. So we can write F net for both the blocks together. So now we are going to take 1 kg and 4 kg as a system, and we are going to write Newton's second law, that is F net equal ma for 1 kg and 4 kg together. So the force which is acting on them is the force because of 10 kg. So force of 10 kg on 4 kg block equal the mass is the total mass, so 4 plus 1 multiplied by the acceleration is 2, which we already calculated. So that's 5 times 2, which is equal to 10 Newton. We can also do it separately for 1 kg and 4 kg, drawing free body diagram for 1 kg and 4 kg separately. We'll get the same answer.